Okay.
Are you allowed to say a vertical stretch by -2?
No. Stretches are always described with a positive number. You should never, when describing a stretch or a squat, you should never use a negative number. Always positive. So you can have a vertical stretch by, that's a vertical stretch by 2. But what does that negative tell you? It's a reflection in the x-axis. Okay. Investment problems. We talked about these yesterday, yeah? So we talked a little bit yesterday about investments and stuff, and so we kind of get down to this idea of if I have P dollars, okay, I'm starting with P dollars. We use the letter P because that stands for what? Principal. Okay, that's how much you initially invest. And then I need to multiply it by some number that represents how much it's going to increase by, and it's a percentage increase. And so it's going to be 1 plus whatever percent it's increasing by, right? Well, what it's increasing by is your annual percentage rate, but potentially it's being divided by however many times you're compounding over the year. So if it's a 3% interest rate, you might not be getting a 3% increase one time a year. You might be getting a 0.75% increase, but you might get it 4 total times for the year. So we take our 0.03 divided by our 4. So R represents the annual interest rate. And then N represents the number of times we're compounding the investment on the year. Oops. Okay. And then we have to raise that to a power, because the power represents how many times we're getting this increase in money. And so what we raise it to is the N times T power, because I want T to represent what? What specific unit? Seconds? Years. T is how many years this money has been invested for. Well, if I'm compounding this investment 4 times over the year, do I just raise that to the first power and represent how much money I have after 1 year? No, that's how much money you would have after getting one of those payments, which is only 1/4 of the year. So we always multiply the number of years times the number of times you're compounding. Because if you're compounding daily, how many times do you have to get this increased percentage in order to constitute a year? 365. So you have to do 365 times 1. If you're doing it for 4 years, that's 360 times 5 times 4. That's how many times you're actually getting your money increased. Okay? And we usually say that this equals A. A is how much money I now have after investing this money for T years. So P is how much you initially invest. R is the annual interest rate. N is the number of times you're compounding over the year. And T is the number of years. A is how much money you have after that amount of time. So remember all that? Yeah. Good deal. As you will learn when we get to trig identities. Sneeze. Oh, it was 1. There goes my sneeze pattern. So what was I just gonna say? What was I got? Oh, as you will learn when we get to trig equations, I'm very bad at memorizing formulas. I am. Formulas that we use a lot, I will eventually get memorized. But I've never been good at memorizing formulas. I just can't do it. So I was in high school, I kind of was a slower math test taker, because whenever I needed to use a formula on the quiz, I would have to use my understanding of math to create it on the fly. Which always worked, but it was a little bit slower, right, than just memorizing it. However, this is a formula that I never forget, because to me it's really a common sense formula. It really makes sense. You should understand how this formula works. This isn't something that you just plain memorize and learn to plug numbers into. It really makes sense why we do R over N, why we add 1. You should never just memorize things. Memorization is not a sign of intelligence, trust me. You got to understand how it works. Okay? So, very good formula. Let's use it. Here's a problem. Let's invest $9,000 at an annual interest rate of 2.5%. Let's have that investment compounded annually. How much money do we have in the account after 5 years? Pretty straightforward. We start with our formula A equals P, 1 plus R over N to the NT. So this becomes A equals 9,000, 1 plus 0.025 over 1 to the 1 times 5. And that's it. You just plug away in the calculator. Because you're increasing it. If I just multiply by 0.025, what happens when you multiply 9,000 by 0.025? You're going to get a really small number. But yet this is supposed to be an investment. My money's supposed to be growing. My answer should be a number larger than 9,000. What you do is you take the 9,000, that's what the 1 is there for, because what's 1 times 9,000? 9,000. Then you add to that whatever 0.025 of 9,000 is.
That one.
Oh, that one?
Yeah, we're trying to
No, because we're compounding annually.
that's for like 1 year.
So I'm actually getting, my money is actually increasing by 2.5% one time every year. And so for 5 years, I'm going to get that increase 5 different times. Did you guys type away in the calculator? What'd you get?
Should we round down like the banks or round up?
Yeah, I don't care. 10,000. Sweet. I mean, because it's
But banks round now.
yeah, I don't know. Just round the way you learned in elementary school. If it's a 5 or both, go ahead and round it up. Because we're not going to try and make a guess at what banks actually do. That'll know for sure. Okay, so $10,182. What if I said I want to know how much time this investment will take to double? So we can plug 18,000 in for A, 9,000, 1 plus 0.025 over 1 to the T, and we got to solve for T. And if you want to do this by hand, you have to use logarithms, which we're not ready for. But one thing, here's something I want to show you today on the calculator. A lot of good calculator stuff today. Your calculator has an equation solver built into it. So if everybody goes to the math menu, and then if you press the up arrow, which actually takes you down to the very bottom, there's something called solver ... Like that. And you might see a screen like this where there's an equation at the top and then a bunch of your calculator's variables down the side. That's because your equation has actually been used before. If not, you might see a screen that looks like this. It says equation solver at the top. Okay? There's one problem with equation solver. It can only solve equations that are equal to 0. Well, it can pretty much take any equation and make it equal to 0, so plug it in here. And it can only solve for one solution at a time. So let's start with a real simple equation like x squared plus 6x plus 8. So x squared plus 6x plus 8 equals 0. I'm just going to go ahead and tell you the solutions of this equation are -2 and -4. Okay? So hit enter. And there's the variable plugged in there. A lot of you, how many of you have different numbers for x? I've got 5. Some people have 10. Some people have 6. The number it's showing you right now is not the solution to this equation. It's whatever number, it's a coincidence. Listen, please. It's whatever number your calculator already has stored in for that variable. So like if I go to the home screen and I take 7 and store it in for x, right? Then if I go to my equation solver, look, 7 is in there for x. So that is not the solution. I have to tell this program to actually find the solution. So with my cursor on the x variable, press alpha and then press enter. See how in big green there's the word solve? There we go. See how there's a black box next to it now? That is telling me that this is an actual solution it is solved for. Make sense? And it's -2. That's great. Now the thing is, I know that this equation actually has how many solutions? 2. It only gave me that one. How can I get it to give me the other one? Well, what if I plug 19 in for x? Right now, the number 19 is stored in for x. If I say alpha solve, it just gives me -2 again. But what happens if I store -20 in for x? And then I tell it to solve? Now it gives me -4. So what is the calculator doing? It's using whatever number is currently stored in that variable as an initial guess. So most likely, it's going to find whatever solution is closest to the number that is currently stored in there. Does that make sense? Okay? Now, here's another thing that's really cool about Equation Solver. I can actually plug multiple variables in. What if I insert the letter A in front of ax squared? And then I press enter. Now I get A and x showing up here. Okay? Let's plug 3 in for A. If I tell the calculator to solve for x, what equation is it actually solving? 3x squared plus 6x plus 8. So if I say alpha solve, why does that happen? The solution is probably imaginary. If I go back up and let's make A -7. Now that A is -7, let's have it solve for x. And hey, there it goes. I found the solution.
I'm confused to know if there's 2 solutions.
It's only going to show you one of them. Where do you think the other solution is? Let me plug in a large number like 100. Right now, 100 is stored in for x. If I say alpha solve, it's telling me the other solution. The 2 solutions are 1.5 and -0.7. So if I plug a number like, listen, if I have -3 plugged in for x, which solution is closer to -3? 1.4 or -0.7? -0.7 is closer to the number -3. So if I tell it to solve now, it uses that -3 as your initial guess. So if I ask it to solve now, it's going to give me the solution that was closer to that initial number, -3. Does that make sense? Now here's what's cool. Let's say I want to create a polynomial that has 0.8. Don't look around, like, seriously. So let's suppose I want a quadratic equation where 0.8 is one of its solutions. What does the leading coefficient have to be? I can actually have it solved for A. So apparently, the quadratic equation, -20x squared plus 6x plus 8, will have 0.8 as one of the solutions. Pretty cool, right? So how is this useful for what we're doing? Well, let's actually plug in our investment equation. Let's type P. Yeah?
How do you clear out the equation that you're solving?
You press the clear button. So you got to press the up arrow so that you're back to this screen. Are you on the screen that says equation solver at the top? Press the up arrow.
Sorry.
Well, you have to have a number type. Just type a number to press up. Oh, you can't leave a variable blank. Okay. So with the cleared out equation, actually type in P parentheses 1 plus R over N to the parentheses N, oops, wrong button, what did I do? Oh, golly. Okay, and T, close the parentheses. And it has to be equal to 0, so what do I now type? Minus A. So you should type this equation, P 1 plus R over N raised to the NT minus A. That's our investment formula, right?
Since I have numbers stored for...
That's fine. You should. Every single one of these variables should have a number stored in for them. So when you hit enter, you should see all the variables you typed in, P, R, N, T, and A, and you should have all these numbers listed there as well. Doesn't matter. Everybody's going to have something different. Everybody's going to have something different. That just happens to be the numbers I had stored. The fact that you're seeing 0 probably means you have never used those variables before. The default value of a variable is 0. Okay? So for this particular problem, what do I want to type in for P? 9,000. So you can type 9,000. What do I want to type in for R? What do I want to type in for N? How about for T? And then isn't A what I want to solve for? So I press alpha, enter. And there you go, 10,182.67. Pretty straightforward. But what's cool about this, one, you know, if this is the only thing you use equation solver for, that'll be in there every time you go back to it. And two, let's solve the second question now. Let's type 18,000 in for A and solve for what? So move your cursor up to where T is and then press alpha enter. So if I leave this investment for 28.07 years, my money will double. Yes. All this stuff down here, I have no idea. You have to write minus A. So if you go back up to where your equation is, because your equation has to be equal to 0, you have to subtract that A to the other side. Some of that. This happens a lot. Probably just that tech error. That tech error? Anybody else have an issue? Calculator issues.
Yeah, the only issues I qualified is
Bobby?
like you actually solved and it says Bobby?
Yeah.
For one, I noticed your NT.
Did anybody else take a while?
No. Yeah.
Yeah.
Oh, they got it.
That's been forever.
Oh my God. Okay. So, you can do other cool things. Like, let's suppose I really want my investment to double after 20 years, not 28. Whoops. So I put 18,000 here. I say I really want it to double after 20 years. What does my interest rate have to be in order to have my money double in exactly 20 years? So now I can solve for R. Bam, if I can find a 3.526% annual interest rate, I can get my money to double in 20 years. Let's say I can't find that. Let's say all I can find is 0.03. All I can find is a 3% interest rate. Well, can I find a base that'll compound this more so that it'll double in 20 years? So if I solve for N, whoa, that probably means that it's not possible to make this double in 20 years. Okay? Now here's an interesting thing. Let's look at this. I'm going to invest $1. Only $1. But I found like the best bank in the world, they're going to give me a 100% annual interest rate. 100%. I'm only investing $1. And they're compounding it one time for the year, and I'm only going to invest this money for 1 year. So $1 at 100% compounded annually for 1 year. How much money will I have at the end of the year? $2. So let's have it solved. Sure enough, it was $2. What if I take the same investment, but I compound it monthly, so make N 12? How much money do you think I'll have at the end of the year?
$2.
A lot?
$2.
$2.61. That's better. Much better. What if I compound this investment daily, 365? How much money am I going to have? $2.71. We're getting closer to $3. What if I have this investment compounded 10,000 times? No. 10 million times? No. 10 billion times over the year. How much money am I going to have, huh? Let's solve for A. Alpha, enter. $2.71. You might even say it's 2.7 Andrew Jackson. That's $8. What? You're saying if I invest $1, so this is my investment, $1 at 100% for 1 year. Apparently, the limit as n approaches infinity of this thing is E. If the number of times I compound this particular investment over the year is infinity, which we call that what? What would we call a compounding investment in infinite number of times? We call that continuously. If I compound this investment continuously, I end up with E dollars for the year, which clearly is the maximum. There's no way you can make this investment of $1 at 100% for 1 year, $3. You can't. It's impossible. You compound the investment an infinite number of times. Okay? And this is a very famous limit. This idea that the limit, as n approaches infinity, of 1 plus 1 over n to the nth power is E. Which is interesting, because as n approaches infinity, what happens to this fraction? It becomes 0. And what's 1 plus 0? And what's 1 raised to any power? You would think 1. But it's E. Why is 0 over 0 sometimes 7? Right? Isn't that when a graph has a hole in it? When a graph has a hole in it, isn't that a 0 over 0? But when you evaluate the limit, you get 10/3, like in our quiz. This is another example of an indeterminate, 1 to the infinity power. If you've got something that's approaching 1 raised to the power of something approaching infinity, that's an indeterminate. The answer could be anything, like E, like 5. Okay? And so that's why if an investment is compounded continuously, we use this formula, A equals P e to the RT power. Or, do you think you could continue using the 1 plus R over N to the NT formula if you just plug in a giant number like 10 billion for N? It would be close enough, and if you're rounding to 3 decimal places, 2 decimal places, the nearest penny, it's probably going to be close enough. Right?
Wait, so that's the eight
Yes.
Yeah.
So this one's for compounding continuously. Does that mean the other one is for not compounding continuously? Oh Alrighty. Let's invest $12,000 at an annual interest rate of 3%. How much money will I have after 4 years if I compound the investment quarterly? And let's also compare that to how much money I would have if I compound the investment continuously. Always. Always. And continuously is what banks actually do. A savings account is actually compounded continuously. So that way, when you take money in and out, it's constantly adjusting. It's not that one time a year that you can trick. Okay. So we're going to have 12,000 times 1 plus 0.03 divided by 4 to the 4 times 4 power. Or in our calculator, we can just go 12,000, 0.03, 4, 4, and then solve for A. So we'll have 13,523 and 91 cents because they want you to invest it for 4 years. What's that? Find the balance after 4 years, so, and then come back quarterly, so that's what they said. One of the 4s is for quarterly, one of the 4s is for 4 years. Right. Then, for continuously, you want to do 12,000 times E to the 0.03 times 4, like that. So that's easy enough on the calculator here. Does everybody know where the E button is? So that will get you $13,529.96. That's not $6 more dollars. That's $6.05 more. Oh yeah. Okay. Makes sense. Yes. Good. You could also have half-life problems, because that is an exponential function. Let Y represent a mass in grams of radioactive strontium, whose half-life is 29 years. The quantity of strontium present after T years is 10, 1/2 to the T over 29. What is the initial mass? Well, what do you get when you put 0 in? 10. The initial mass is 10 grams. How much will be present after 80 years? Just plug in 80. Wow, really difficult. Half-life problems are easy. I mean, this just totally makes sense. The half-life is 29. 29 over 29 is 1. That's when you multiply by 1/2. Totally makes sense. Yeah, even that's not that bad. Population growth. The approximate number of fruit flies in an experimental population after T hours is given by 20e to the 0.03 T. So there's an example of what is e raised to the 0.03. 1.0304. So you could argue this is actually a base 1.03045 exponential function. That's a function that probably doesn't grow very fast, right? So it's so close to 1. Find the initial number of fruit flies. Blah. Plug in 0. How large is it after 72 hours? Blah, 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 blah. That's really easy stuff. There you go.